Hey guys, this is Mitch with Finepoint CGI, and today we're going to talk about how to do unit tests inside of C# with Godot. So we're continuing our C# basics little series here where we talk about basically the beginning of C# all the way up to basically getting you kind of acclimated to the language and to the different aspects of development in general. So in this video, we'll be talking about unit tests. So we're going to go through what unit tests are. We're going to talk about how unit tests work and why they're important. We're going to talk about how to do a very basic positive test. We're going to talk about how to test mouse button clicks. We're going to talk about how to test keyboard inputs and things like that for your player controllers. And we're going to talk about how to do a negative test as well, because negative tests are extremely important to properly testing your code. That's what I have in store for you guys today. Let's go ahead and get started. So first off, we got to talk about what unit testing is. So what is unit testing? Well, unit testing basically focuses on testing the code itself. These unit tests are usually for functions or methods or classes that exist inside of your code. And the whole goal of unit testing is to verify that each section works. Now, typically people think unit testing is a giant waste of time, and in some cases it is, in some cases it isn't. It really just depends on how you unit test. And one of the big benefits of unit testing is that it really helps you catch bugs early and make sure that code that you write in the future doesn't break our existing stuff. And typically when people focus on unit testing, they focus on testing utilities and things like that. So it's not always about testing everything in your code base. It's about testing the stuff that kind of makes your stuff run, if that makes sense. So what is the unit testing lifecycle? So typically the life cycle is simple. You plan to understand what that code is going to do, and you need to know what kind of functionalities you're going to try to test. Then you actually write a test case. So you say, this is kind of what I think it needs to do. I need to validate these specific aspects of that function. And then you run that test case and make sure it works. And then finally you review it and say, hey, is this a failing test? Is this successful? Does it maintain everything that I need it to do? And is it testing everything as expected? And then finally, you maintain that, because a lot of times people will write a bunch of unit tests and then forget about them and then run all their unit tests, then all of them are failing. And it's not necessarily that your code itself is wrong, but sometimes it's because your unit test is wrong. So a lot of times you have to maintain those unit tests just like you maintain regular code. Let's take a look at an example unit test. So this is an example unit test. You can see here, we are adding two numbers. We're summing them and we're saying it should be 8, right? And then we're running our add util here, our little math util.add, and we are adding the two numbers together and then returning that result. And you can see here underneath the int actual sum, you basically are receiving that sum and then you're checking what the result is and if it is properly equal. So you can see the expected sum is equal to the actual sum. So this would be a passing unit test. And so that's really cool. But what are some of the cool frameworks that we can use for unit testing? Well, in C# we have quite a few of them. Really, there's hundreds and hundreds of them. But the top two are XUnit and NUnit. And they're basically the exact same unit testing framework. I mean, if you've worked with one, you've worked with the other. XUnit is free and open source, and it's extremely well known. I use it at work as well as NUnit. I use both of them, but XUnit is slightly less flexible than NUnit. NUnit is a big old open source testing framework that has lots of features and it has a lot of customization capabilities. So typically you'll choose XUnit if you need just some unit tests, but NUnit if you want some really flexible tests, typically, though you can more or less mix and match both of them. If you work with one, you can work with the other. And then finally, there's GDUnit. Now, this one is a bit different. It is designed for Godot. And since it's designed for Godot, we'll be using that in our tutorial here, but just know that you can use XUnit and NUnit as well if you prefer. So don't box yourself into just using GDUnit because I'm here using it. But we will be using GDUnit. Now that we have kind of a basic understanding of what unit testing is, let's actually jump into Godot and run through a basic unit test. So if we open up Godot here, when we take a look at it, you'll see that this is the basic scene that I created in our first tutorial where I introduced C sharp, right? And basically, we're going to be using this as our basis. Now, if you don't have this, go ahead and drop it into my GitHub link below and download this project, and then you can start from here. But basically, what we have is we have a line edit, a button, and then a terminal here. Now, this is new to the actual thing. The reason why is because it makes it a little bit easier to test your code, and that's why I added this in here. But just know that this is new. Now, if we look at the code here, we can talk about that real quick. If we scroll down here, you'll see that there are a bunch of functions here. And you'll notice that there is an addition of a new function called print to terminal. Now, print to terminal is a very simple function. It basically just goes out and drops that message into that text edit. So I just want to make sure that you guys are aware of this so you're not stepping into this from the previous tutorial and going, whoa, hold on a minute, like this wasn't a thing. So that's kind of the idea. Now you'll see that I changed all my GD prints to print to terminal. That way we have all of those things. Outside of that, nothing else in the project has really changed. I just wanted to make sure that you guys are aware of these small changes so that way you guys aren't completely up a creek when we go through the tutorial. Now, in order to actually do this, we need to download it and install GD unit. So if we go to asset.lib, we type GD unit like so, you'll see that there's a GD unit 4. So we'll go ahead and click on that guy. We're going to click download and we are going to go ahead and install it. And that's going to add in the GD unit extension into Godot. So it's going to give us a full unit testing library built right into Godot. So we'll hit OK. We'll go to editor. We'll go to project settings, plugins, GD unit. We'll hit enable, and you will see right here, there is a tab. Now, this tab is actually really cool. It has all of your unit tests basically laid out right here. So you can actually see when they pass or when they fail. Now, a lot of times when people create unit tests, what they do is they go in, they right click on their RES folder or their script folder or wherever, and they'll come in and hit create new folder and they'll type unit tests like that. And I should not have capitalized E. So we'll do that like that. And now once we have this, we can basically just right click, create new script, and then we'll just call it unit test tutorial. Now, typically when you do unit testing, and you can get rid of the template, we don't need that. Typically, you want to create unit tests for each class as a class, but in our case, I'm just going to use unit test tutorial. So that way I just have a centralized location. It's going to be a little bit easier, but in my experience, I usually like to go in and actually create unit tests for each class, if that makes sense. And now we can go ahead and open it up. So we'll double click on that and it's going to open up like this. Now, some of the things that we're going to be unit testing in here is I'm going to show you different ways to unit test some different things. So first, we're going to unit test a very basic function, and then we'll step in and unit test something that's a little bit more difficult, like a movement script or something like that. So we'll probably have to build that, but we'll need to do that. Now, there's a lot that's going to need to change here for us to be able to do unit testing. Now, if you remember from our original setup in our example unit test, it shows that there is a test above that unit test. So inside of GD unit, which is the one that we're actually going to use, we need to basically tell it to see this. So let's get rid of this guy here. Let's get rid of our inheritance right here. And let's come up here and go bracket, and let's say test suite. Now you'll notice that it has an underline right here. See this? It says type or namespace test suite could not be found. Are you using a derivative or an assembly reference? That means that we need to get our using statement in. So what can we do to actually do this? Well, if we click on this little 3 dots here, terminal, new terminal, and if we type .NET add package GD unit 4, enter, and it's going to go ahead and install GD unit. Now you'll notice that it looks like it says there are no versions available for GD unit. So let's go ahead and do GD unit.api. Let's pull down the API, and then we'll also need to pull down the test adapter. So we'll type .NET add package GD unit for .test adapter, like that. And that's going to go ahead and pull down that. Now you'll see that it restored them. And the reason why I restored them was because I already had them installed at some point in time in another project. So it just pulled it from my cache, but you should see it, download it, and install it. And now from here, we should be able to come up here and say using GD unit 4. And now suddenly this works just fine. Now we have to find a function to test. So let's go ahead and take a look at our utilities functions right here. And let's take a look at them. So if we pull this over a tiny bit. So we have a load budget from JSON. That's going to require us to actually have some JSON information. So what I think would be good is to do a save budget to JSON. You have to pass it a budget and you have to serialize it out. It's going to save it out to save.json. So what I'll do is I'll come in here and say public void test save budget to JSON, like that. And then what I'm going to do is I'm going to create a new budget. Now you can see that VS Code is attempting to help me here. So that's good. But I'm going to go ahead and code this out manually. So we'll do budget is equal to a new budget, like that. And then we'll name our budget. Well, now it's actually refilling all this in. So let's pull this across. Let's get rid of all of this. If we take a look at our budget, I'm going to have to get rid of this add-on real quick. There we go. After a reboot, that's going to get rid of that plugin. So it stops doing that. So I can actually teach you guys how to actually do this. So we're going to take a look at our budget object. So if we take a look, we can have a name, date start, date end, income, and expenses. So let's do a name is equal to test. We're going to go ahead and say budget dot expenses is equal to a new list of expenses. And you'll see that it says the type or namespace list could not be found. So we'll go ahead and quick fix that, grab our system collections generic. We're going to do expenses is underlined, type or namespace expenses. I thought we had a transaction like that. And then we're going to come in here and do transaction is equal to a new transaction. And we could probably go out to, I'm curious if we could do our app manager, if we have some code that creates transactions right here. So we could just copy this guy here, paste it, get rid of this, and then we'll do quote test date time dot now, amount is 100, type is transaction type home, like that. And there we go. And then we could just add that to our expenses like that. And then we can go ahead and do utilities dot save budget to JSON, like that. Now, this budget is not going to, this function here is not actually super unit testable because we have a globalized path here and user save JSON. We should probably pass in a name parameter. We'll say string name save.json, save like that. And then we'll come in here and we'll just go quote plus space name space plus quote, like that. And that will give us a way to just kind of get a different name. That way we're not breaking our previous code, because part of our problem is going to be that we can't really save like multiple versions of a thing without doing that. So I'm going to go ahead and do that. And then we'll come over here and we'll pass in comma test for our test.json. And then we actually can load that data and verify that it's good. Now, unfortunately, there's no real way to unit test just the saving without loading it. So we're going to need to actually load our budget. Now, I'm going to do a comma budget name. That's fine. So we'll say loaded budget is equal to a new budget. And then we'll say loaded budget is equal to utilities load budget from JSON, and then we're going to pass in test.json like that. And that will go ahead and load that budget. And now we're going to want to make sure that this object and this object are basically the same, right? From what we saved to what we loaded. And this is going to test both of these functions pretty well. Now, the easiest way to do that is to say assert string, and then we can pass in what our string is currently. So we'll say loaded budget.name dot equals budget.name like that. And then typically inside of unit tests, you only want one assertion, right? You don't need multiple assertions. But in this case, I'm going to cheat a tiny bit and go ahead and just do another assert string and do dot expenses 0 name is equal to budget dot expenses 0 dot name like that. And if we want to, we could do the same thing, but for assert int and then do expenses dot amount and then expenses dot amount like that. Cannot convert float to int, so we'll say float like that. And I'll go ahead and not assert the date. I'm not super worried about that right now, but you get the concept of how this works. So once we have this, we're pretty much good to go, right, for our test, because we have what's called our assertion, which is right here. So if we break this down, what are we doing here? So first things first, we are setting up the information. So inside of unit testing, how it works is you have what's called the setup, then the test, then verification. And then from here, you would have something like cleanup. And I'll explain cleanup in a minute, but just remember that cleanup is a thing. So from here, we should be able to go out to Godot here, go to GD unit, click on unit tests, right click our unit test tutorial right here, and click debug. Now what that's going to do is it's going to fail to build apparently. So it's going to actually go and test our stuff, providing that it didn't fail to build. So let's take a look as to why it failed to build. So if we click build, failed to build project, no overload method save budget to JSON takes 2 arguments. So if we double click on that, you'll see that this is doing 2 arguments. That's because we didn't save our utilities function. You can see this little icon up here. So I'm going to go ahead and save that. And then we will right click debug unit test. And you'll see it's going to do a TCP connection, and it has successfully passed that test. So how do we know it actually did what we wanted? Well, if we go out to project, we go to open user data folder, and then we see we have a test.json. If I go to my preview, you can see what it looks like. There's the data right there. That's exactly what we put in there, right? We have our name, we have our ID, we have our test, we have our date, we have our amount, and we have our type. Now you can see our ID is a GUID, so that might also be another good test, right? Is to pull this GUID back and validate that it is exactly the same item. So you could do that by coming in here and doing assert string load budget dot expenses bracket 0 dot ID equals same exact thing expenses 0 dot ID. And there we go. Now we're going to also need to .to string this because unfortunately there's no way inside of Godot to handle GUIDs like that. They don't have a assert GUID type. So that's something that I think is a sad limitation, because if we look at assertions dot assert, you can see that there's a bunch of things that you could do, but none of these are actually useful for us for what we're trying to do. So we'll go ahead and get rid of that. We'll save. And then you'll see when we come back here, we can right click on this. We can click up here on this and hit run unit tests. And what that's going to do is it's going to run our unit tests. You'll see it's going to fire off, and it finished and was successful. So that's basically the basics of unit testing. Now from here, you have the basics, right? This is how you do unit testing. But let's take it a step further. What if I wanted to click this button and I wanted to use that button and test to see if that button did the right thing, the thing that I expected it to do? In order to do that, we need to actually load our scene. So let's go back to our unit test here, and let's come down here and say test case public void and basically just copy this bit of code here. What I'm going to do is I'm going to rename this as test. If I can double click on it, test mouse button click, which I need to capital that B or else it's going to kill me. There we go. And then we will go ahead and hit enter bracket and we'll go from there. Now, what we need to do is we first need to actually load our scene. So let's come in here and say var runner is equal to iScene runner dot load like that. And then we'll pass in res : / we'll pass in the path of our scene. So our scene's located in resources and it's called test space scene.tscn. And you know that by taking a look at the scene name, it's right here, test scene. It's located right here. So that's how I came to that conclusion there. So we'll go ahead and do that. And then we'll come in here and we'll say runner dot. And basically what this is, the iScene runner is it loads your scene and gives you access to that scene. So it loads it into memory and allows you to execute different things. So I want to move my mouse position to where my button is. So I'll say set mouse position to a new vector 2 and we'll put 316 comma 52 like that. Okay. And I'm getting that because if I take a look at this button here, you can see our button's location right here is 315 and 49. So I'm getting it to go 316 52. And the reason why is because right here in the upper right hand corner, it's right here. So if we wanted to click on the button, we need to offset our mouse a tiny bit from the upper left hand corner. So it'll click somewhere in here. So it'll be able to click that button. So we just want to make sure that's inside the bound. And then from here, we need to wait, right? We need to wait a frame for that mouse to actually move. So we'll say await runner dot idle frame like that. And we're going to await that idle frame. Now, first things first, you'll notice it says async here, and you'll notice that it says await. So what does that actually do? Well, async means that this function is going to run outside of the normal call stack, and await means it's going to wait for that function to get finished before it continues execution. So that's basically the point of await, if that makes sense. So now all we have to do is go runner dot simulate mouse button press, and then we'll choose our mouse button. So we'll type parentheses mouse left because we're going to do a left mouse button press like that. There we go. And now we need to await another idle frame so that way we can catch that event when it's done. And now all we have to do is go ahead and fetch this object here. Okay, because if you take a look at this code or how this thing works, is if I hit press me, you'll see that it says choice was not 1 or 2, John, Madison, Mitch, Victoria, and Alicia. So you can see right here, it has those values. So we need to make sure that we read this value and then check it against what we expect it to be, which is those values, right? Because we're not putting anything in for, 0 or 1. So we'll come in here and we'll basically just say var output is equal to runner.findChild text edit, comma, true as text edit, like that. And then we can actually assert our string, right? So we can say assert. I believe we have to do assertions. So dot assert string like that. And we can do output dot text dot is equal, not is empty, to some kind of value, right? Well, if we look, you can see right here, the choice was not 1 or 2, John, Madison, Mitch, Victoria, and Alicia. So we can just grab this right here, paste it, and then we can basically hook this up. So we can do, if we hit click, shift, click like that, we add in /n for new line, and then we can do this backspace, and that will basically handle it, I think. We'll need one more, I think, at the end, so that way it actually has that extra new line like we expect. And now we can basically reset our output text, because when you load a scene, if you are testing anything else in that scene, those changes persist on the next run of the test. So you want to be cautious of that. Something that I ran into earlier. So we'll say output.text is equal to empty. Now, you may or may not need to do this, but I really believe that it's a good idea just in case. So now from here, we should be able to come in here, go into our GD unit test, scroll up, right click, debug unit test, and it should just run through. And we have a failed unit test. So you can see here, it says you must return a task for asynchronous specified methods. So this one didn't even run. It wasn't even allowed to run because this is not returning what's called a task. A task is basically telling C# that it is a asynchronous code piece that can be ran asynchronously, if that makes sense. So we'll say task like that. And then let's try that one more time. So we'll go ahead and run it. And you'll see we have a successful unit test. Now you might be asking, okay, hold on. So all you've ever shown me was successful unit tests, right? So what happens if we come in here and we actually go into our app manager 2, which is this little bit of code here, and we comment out printing to our terminal right here, right? So we're commenting out the ability to print to that little output terminal right here, right? So if we do that and we right click and we click on the little button here, you'll see it's going to load it, and then we get a failure, expecting to be equal to choice was not 1 or 2, John, Madison, Mitch, Victoria, Alicia, but is empty. And that's kind of the power of unit tests is when I go in and I make that change, because my previous test case said that I expected this and I got this, now we know that something went wrong in our code and somebody broke something somewhere. And that's the power of what unit tests are all about, is how can we properly test our stuff? Now, one of the big important things with unit tests is you want to make sure that your unit test only tests one case per unit test. So for instance, if you take a look at this function right here, the on button down. So when we click our on button down, that's basically what we're testing, right? Choice was 1, choice was 2, choice was not 1 or 2, right? We need to have 3 unit tests because this if statement basically means that there are 3 possibilities to this function. So we need to test it in 3 separate ways for it to be a successful test. So for instance, if we grab this guy, copy it, and paste it twice, we can say test mouse button click 2 and test mouse button click 3, or technically you probably should do 1 and 2, I guess, because technically the choice would be 1 or 2, right? But we'll burn that bridge when we get there. So if we take a look, you can see choice was 1. We'll copy that. We'll go over here. Choice was 1. And then choice was 2, right? Go right here. Now we need to change our code so that it actually matches up with what we expect. So we need to be able to set our choice inside of our unit test. So much like how we did here, where we actually grabbed our text edit and we read the text edit, we could do the same exact thing here. What we can do is we can come in here and just say var line edit is equal to runner dot find child line edit comma true, like that. And the true here basically is whether or not it's recursive. So the nice thing about this is it's going to recursively go through your node tree to try to find the child that you're looking for. Now, this is good and bad. What it means is that it's going to go and try to find one child by the name of line edit. If there are 2 children that are named line edit, it's going to come back with the first one. So you want to be cautious of that. Just keep that in your mind. And then we're going to set our line edit equal to something. So we'll say line edit dot text. Oh, we're going to need to cast this as a line edit like that. And then we can do dot text. And we're going to make that equal to 1 like that. If I remember correctly, oh, this is 2 actually. So we'll do 2. And then we'll just duplicate this little bit of code here. We'll come up here and we will paste it right here as well. And there we go. Now, this should test both of them efficiently and correctly. So if we head over here, we come in here, hit the little debug icon, you'll see that it failed, expecting to be equal to choice was 1. And this is expecting choice was 2S, which wouldn't work because obviously we don't have a 2S. So this just doesn't work. So the question is, what is being fired off when we do this? Because I thought it would just be choice was 1, choice was 2, 2. Yep, that's correct. Line edit text is 2. Line edit text should be 1, not 2 for that. That's my fault, but choice was 1. So this looks correct to me. I give myself a little bit more space. We rerun this real quick. Choice was 1, but choice was 2. Choice was 2S. Okay, so hold on a minute. Did we not save? Yeah, we didn't save our unit test tutorial, so let's try that again. Refresh. There we go. So the reason why it was failing was because we were passing in a 2 for our first case right here, which was looking for choice was 1. So it should have been a 1. So this should have been a 1. And then this, we must have bumped S here when we did choice was 2. So that's all right there. So now we've covered simulating mouse presses, but what if we wanted to simulate keyboard inputs? Well, thankfully, we can actually do that. It's actually really easy. If we come in here, let's just quickly drop in this scene, right? Like that onto it. I'm just going to drag the basic right. That way it just exists. So you can see it right here. I'll just drag this guy, I don't know, somewhere. Well, I'll just keep him here. I'm fine with that. We'll make it a little bit smaller just because I just don't like how big it is. I always make it smaller. I just have it at this point. I'm going to right click my character body, attach a script. I'm just going to do a template of a character body 2D basic movement. And I'll just do character body CS. That's fine. And we'll come in here and we'll rip gravity out because I don't want to deal with gravity right now because it's going to make the unit testing a little bit more complicated. But once we have that, we'll have a very basic left and right character movement script, right? So I'll be able to hit left and right and it'll be able to move the character left and right. So you can see here, left, right, the character can move left and right. Nice and simple. So what we can do is we can actually take this and test this. So how do we actually test this? Well, thankfully, it's really easy. We come in here, we can go into our unit test tutorial. Let's go ahead and minimize a couple of these test cases. Let's come in here, hit enter and do bracket test case like that. Public async task test character right movement like that. And what we can do to test our character movement right is first we need to load our scene, which is the same scene that we've loaded the last time, right? So it's just this RES TESCN. So we'll just load this guy and we will go ahead and take that. And then once we have that, we need to grab our character body 2D. So var character is equal to runner.findChild, quote, character body 2D like that. And then we'll put a semicolon to that. And we will do as character body 2D like that. And now we can do runner dot. And this is where the magic kind of happens. Simulate. And you'll see we have a bunch of different simulations. Simulate frames, which allows you to simulate actual frames of time. So you could say simulate 10 frames, right? So simulate 10 actual frames going by. So if your game runs at 60 FPS, if you simulate 60 frames, it's going to be 1 second worth of time in your game. So that's really useful. Key press is basically if you press the key down. Key pressed is if you pressed it down and released it. And then key release is if you just release the key. And then, of course, you have mouse button press, pressed, and release. And then mouse move, which allows you to actually move the mouse. And then mouse move relative, which allows you to move the mouse relative to where it is currently. So that can be really useful. What I'm going to do is I'm going to simulate key press like that. And I'm going to go with key. And I believe this was what? Test character right movement. So we'll say key dot right like that. And then we need to wait, right? So we need to wait for some time. So what I'm going to do is say await space runner dot await. And you'll see we have a bunch of options. Idle frame, which we did earlier, which basically lets one single frame pass. We have millis, which is milliseconds. So we can await for a specific second time frame. This is really useful when you test your character controller, right? Because you can await for a specific seconds of time. Or we have signal, which allows you to wait for a signal to get fired. Now, unfortunately, signals inside of Godot is a little bit finicky with C sharp. So typically I wouldn't tell you to use a wait signal if you can avoid it. But if we go with millis like that, we can go ahead and put in 1000, which is 1 second worth of time. And then we can go ahead and say assert float like that. We'll pass in our character body dot x, and we are going to go character body dot x. Well, that's not quite what I want. Actually, it's going to be character dot position dot x dot is, and you'll see that we have a couple options: is less, equal, even, greater, greater, equal, is in, is less than equal, is negative, not in, not negative, not zero, null, odd, zero. There's all sorts of them, right? Well, since we're moving our stuff to the right, it's going to be greater than 0, right? Because our actual character is at 0, 0. If you see right here under transform, it's at 0, 0. So if it moves to the right, you'll see that that number goes up. So that's how we know if we hit the right key, it's going to go up. So if it is greater than 0, then we know that we've successfully passed our test. And now we can do the same thing, but for the left movement. We can come in here, bam, left, and we can say position X is less than 0, and we can go ahead and do key left like that. And we can go ahead and do this. We can click debug, and let's let that boy run and see what happens. So it's going to run. It's doing the right movement. It's doing the left movement, and it successfully passed. And now we are testing the right and the left movement of our character. Our character actually moves to the right, it moves to the left, and then it succeeds or fails. And how we know that is because if we were to swap this, so is less, right? So let's say X is less, right? It's moving to the right, so this should fail. So if we go like this, you'll see that that failed. Expected less than 0, but is 300. It moved 300 units in 1 second. And the cool part is if you know your character controller really, really well, you could actually come up with a way to say, okay, after a second, it should be at 300. That's how fast the character moves. So now I know, right? And you could actually come up with a way to say, I want to make sure that they moved exactly 300 units after a second. And that can help make sure that your unit test is actually really well put together. Now, obviously, I failed that, so I'm going to hit Control Z and then Control S. And that should be good to go. So what if we want to test something multiple times, but with different values? That is where overrides kind of come in. So if we come down here, let's build another test case. Let's go ahead and test in our app manager. I'm pretty sure in our category list item here, we have a update actual right here, right? So this is a really good use case for this because you can see how it takes in a float. Now, the reason why I'm showing you guys this is because this is really good unit testing behavior, right? You have to look at this and say, okay, this takes in a float. That means that I can put in any value I want. So how do I know if I put in a 2, if it's going to be correct, or if I put in a 7, if it's going to be correct? But I don't want to create a unit test for each one, right? I don't want to have to come in and say, public async task, test, update actual, right? And then bracket, and then come in here. Well, we have to load our scene. So var runner is equal to iScene runner dot load, and then pass in yes slash, and then it would be category underscore list underscore item dot tsn like that. And then we'd want to go ahead and run this little function here, right? If you are loading a scene, so if you take a look at this, previously we loaded this scene, right? But what if I wanted to execute something on the category list item? If we look at the code on category list item, it actually exists right here, right? It's a function, but it's right here. So I can't get its children like I normally can. So what do I have to do to actually execute that? Well, that's where invoke comes. We can say runner.invoke bracket update actual. And that's going to run the function that's locally on that script here. So you can actually just call out this function and then pass in any parameters with a comma like this. And there we go. And then since this has a label actual and it sets the text, you can see right here, to string, and it's actually doing the actual and difference. Let's go ahead and get those values. So var actual is equal to runner find child, actual and true. And then do the same thing, but for difference. So we'll just grab this difference, lowercase d, and then we can come in and assert that those are correct, right? Because these are labeled, I guess, as labeled, right? We need to make sure that we tell C# it's the right type. So we'll say as labeled. And then we can just come in here and say assertions dot assert string is equal to, and then we could just pass in that value, whatever value we're trying to assert it to, right? So it would be 1.toString, right? Something like this. And I know that typically you wouldn't do 1.toString. That's really weird, right? But don't worry about it. Like we'll go through this and explain why in a second. I'm just going to show you guys how this works. So this should just work. If I come in here, I go to GD unit, I hit play, you'll see in a second. It's going to test our character movement. And it didn't even show up as a unit test. That's because we didn't put test case up here. See this? So bracket, test case. Now if we run this, well, it failed, but it says expecting to be equal to -1, but is 1. So that's not good, but I'm assuming that's because I did actual, not different. So that's my fault. So that's just me being dumb. But what if I wanted to test if it's equal to 2 or 12 or 20 or whatever, right? What happens if I want to fuzz that value, right? If I want to make it different? Well, that's where we pass in parameters in our test case. You can come in here and go parentheses 1. And then we can pass in int value like that. And then we could grab this guy, come down here, paste it, and paste it like that. And then we can duplicate this and say 5, 20, 12, 15, and 18, let's say, right? We can come over here, hit play, and you'll notice in a second, it's going to duplicate that test a bunch of times. You'll see right here, well, it just finished, but you can see right here, 6 of 6, update test actual. You can see, and I spelled actual wrong, but that's fine. You'll see here, it did each individual test individually. It allows you to take a look at them and see what they look like. And if you click on GD unit console down here, you can see each one, which one's passed, which one's failed, how many errors you have, and the final summary of your succession or failure of your project. So, one last thing before I leave you guys with these unit tests. Let's talk really quickly about what's called negative testing. So, what we've been doing up to this point has been what's called positive testing. We've been saying, yeah, let's save our data to JSON. Let's load our data from JSON, right? And we're basically just assuming that everything's going to be correct. But what we haven't tested is what happens if we pass in something broken. What happens if it's broken? What if somebody uses our stuff in a way that is unexpected, something that we didn't really plan for? Well, that's where negative testing comes in. So if we come in here and we build a unit test, so bracket, test case, public, void, test, negative, save budget to JSON, right? And if we take a look at our test save budget JSON, what if we copy all of this, right? And instead of test, let's go with N, EG. And then instead of test, let's go with NEG for negative. And then let's go ahead and just go budget is equal to null, right? this should never work, right? This should error out in some way. If we hit Control S and we come in here and we run this unit test, what happens if we use it in a wrong way? Well, we got a failure. You can see we got a hard failure actually right here. Object reference not set to an object. And it says line 47. So where did it blow up and why? Well, if we take a look at our code, line 47 is looks like here actually. So it might have just taken it and accepted it. Let's take a look at our budgeting app here. We have a negative.json. You can see it has null. So this code is allowing you to write an empty file, effectively writing a null value. So what does that mean for us? Which means it probably loaded it as null. So really what this is doing is if we come in here, we could say assertions dot assert. I believe there is a assert object, I believe it is. And then we can go dot equals null, like that. So you can see I'm testing if it's correct, right? If it has data to save. But what happens if it has data not to save, right? So we can come in here and see what happens if we do that instead. If we run this, what does it do? Now that I kind of reconfigured our unit test to kind of handle that null information, I'm curious what it's going to do. So if we run through this, well, first it failed to build because 4738 is mad because I didn't do an extra thing. So we'll try that again. And it still failed. Object reference not set to an instance of an object. And my guess is because I did it like this, not this. Dot. There we go. Let's see. Is not equal, is not null, is null. There we go. And that should pass now. So if we try that, and you'll see it was successful. Now the question is that what we want it to do, right? That's a negative test. That's testing what happens if we don't use it correctly. And you want to make sure you have positive tests, and you want to make sure you have negative tests. What happens if you pass in bad data? What happens if you pass in a brand new budget? Does it work? Does it not work? What happens if you pass in something that's unexpected? And that's kind of the goal of what a negative test is for. So you want to make sure you cover both just in case. So at this point, you have a very basic primer of what unit tests are. You understand what they are, why they're useful. You understand the different frameworks and which one I specifically am using for my Godot projects. We talked about how to do positive testing. We talked about how to do mouse movement and clicking and things like that. We also talked about how to do keyboard inputs in your project. And finally, we talked about negative testing and why it's super important to know how to do that. So this should be a pretty good primer on how to do unit tests. So if you like this video, go ahead and hit that like button. Hey, if you dislike this video, go ahead and hit that dislike button because I'm here to make content for you guys. This video was a viewer suggested video. So if you have any suggestions, please leave them in the comments below and I'll be more than happy to add it to my GitHub or jump on my GitHub and you can actually submit tickets right there. That's where I keep track of all of my projects and everything that I work on. So I will see it if it gets submitted there. And hey, if you have any questions or comments, leave them in the comments below or jump on my Discord. Link is in the description and anybody there will be more than happy to help you out with any issues you might be having. But that is all I have for you guys today. So thank you so much again for watching and I will see you all next time. Thanks.